Hey everyone, I wanted to cover a couple of examples for you from section 6.4, which dealt with complex fractions. This first video is going to take a look at a simple one and is going to be using the division method. So the example that we're going to take a look at is going to be as follows. So we have 10 over 3x, and that rational expression is going to be all over 5 over 6x. So what I want you to note here is that this is actually kind of two fractions that are going to be used to create another fraction, and that's what makes it a complex fraction. What we're going to go ahead and do here is we're going to use the division method. And basically what the division method is saying is that we are going to rewrite the problem to our advantage. We're going to bring this back to something that we've seen before. If you recall, a division bar or a fraction bar is the same thing as a division bar. This allows us to rewrite the problem. So this can be rewritten as 10 over 3x, and instead of this division bar here, I'm going to replace it with the operation sign for division. So when we read this, it's 10 over 3x divided by 5 over 6x. At this stage in the game, we can go ahead and skip the first one. So this will stay as 10 over 3x. We can flip the second term. In other words, we want to take the reciprocal. And by taking the reciprocal, we change this division problem into a multiplication problem. Now we can go ahead and simplify this down. Well, a 5 will cross-reduce with the 10, leaving us with a 1 in the denominator and a 2 in the numerator. A 3 will cross-reduce with a 6, leaving a 1 in the denominator and a 2 in the numerator. And the x's will just cross themselves out. They will cross-reduce entirely. There's nothing left. This leaves us with 2 times 2 in the numerator, or 4, over 1 times 1 in the denominator, which is 1. This is what WAMAP will want to see. It will want to see 4 over 1. For your exams, you can simplify this further and just say that this is 4. Now, let me show you the same idea with the least common denominator method. Okay, so I'm going to rewrite the same problem that we had, so 10 over 3x, all of which is over 5 over 6x. So what you want to do is you want to focus your attention on the denominator of the top rational expression and the denominator of the bottom rational expression. So what is the common denominator, or least common denominator, of 3x and 6x? Well, what I can say here is, if I were to multiply this one, this top rational expression, by 2, 3x times 2 would give me 6x. So I can rewrite this problem so that it's 20 over 6x. And I don't have to make any sort of adjustment to 5 over 6x. It already has that least common denominator of 6x. So I'm just going to leave that alone and say that this is 5 over 6x. What this allows me to do is, note that the denominators of both rational expressions are identical. That means that I can just cross them off and rewrite the problem to see what I have left. Well, I have a 20 in the top and a 5 in the bottom. 20 over 5 simplifies to 4 over 1, or again, 4. So either method will work. I would strongly suggest that you do become familiar with both the division method and the LCD method and see which one works best for you or resonates the most for you.